Right, so let's start looking at actually doing some algebra here and figuring out the inverse of each function. So remember, in a mapping, all you're doing is you're taking the original point x, y, and you're just going to flip them to y, x. So wherever there was an x, put in a y. Wherever there was an y, put in an x. Well, that's pretty easy to do. Look at our first question. This one is f of x equals to 3x plus 2. So this f of x actually used to be y, right? That's just another way of saying y, but we like the input-output machine stuff that we talked about all the way back in grade 10. So that's why we use f of x. So all we have to do is just interchange them. This becomes x equals to 3y plus 2. Now, solve for y. This is the best part. Subtract 2 from this side, subtract 2 from that side. That's gone. There we go. We've got x minus 2. Now all we got to do is divide by 3. Divide by 3. We end up with y equals to, you know what? Let's just put that fraction up front. 1/3 x minus 2. Now, the cool thing about this is this. You have to use the proper notation, right? You have to indicate that this is actually the inverse function. So let's use the proper notation. F of minus 1 is the proper notation. But about 1/3 x minus 2. Now, I know what you're saying. You're probably saying to yourself, well, wait a second. Are you sure that that is the inverse of this guy? Is that really the inverse? Well, you know what? Let's figure it out by graphing it. I'll show it to you, right? So first things first is I'm going to get my calculator going here. And the first line I'm going to put in is I'm not going to put in the two lines. I'm not going to put in the two equations. I'm actually going to put y equals to x down first. And you're probably saying to yourself, well, why would you do something like that? Because remember, when you graph this, it gives you that line. And this is actually our mirror line. This is our line of reflection. Remember how we reflected either over an x-axis or over a y-axis? Inverses are reflected over a line y equals to x. Ah, neat. And this line actually goes at a 45-degree angle right through the two quadrants. Pretty interesting now, isn't it? Now, let's go and actually put in our equations now. So going back to this, we have a 3x plus 2. Let's put our original in there. Okay, so y equals 2. There we go. Mouse it down to here. 3x plus 2. And let's graph it. Bada bing. And there it is. There's our 3x plus 2. And lo and behold, sure enough, it's going to cut across this mirror line. And do you remember from whenever we do reflections, when you cross the mirror line, that's going to be your invariant point. Aha! Now, let's put the other function in. The other function, of course, was 1/3 x minus 2. That's our inverse function. 1/3 x minus 2. Okay, so here we go. Back to here, down to here, put in brackets, 1/3 bracket x. Oops, forgot the bracket. What's you doing? There we go. X minus 2. Perfect. Excellent. Let's graph this. Check this out. This may freak you out. Here we go. Ba-da-bum. And sure enough, just like I said, there's the invariant point. Boom. This is the original, and this guy over here is the inverse. Let's prove it. Now, remember, in order to do a reflection, you have to go 90 degrees towards the reflection line. So check this out. I'm going to pick a point right about here. I don't care what it is. I'm going to go directly at 90 degrees to the reflection line. And check this out. This distance here is exactly the same as that distance there. And check it out. There's your reflected point. This point now becomes this point. Isn't that cool? So it actually does show the reflection. If you want, you don't believe me, go do a reflection out here. Here's our original. Go 90 degrees right at this line. Bada boom. Okay? Do the same all the way to this line. Da-da-da. There's the original point. There's the reflected point right across this wonderful thing we call a mirror line. So it works out really, really cool now, doesn't it? Okay. So now let's go back to this and let's do the other question that we have here. The other question we have here, and let's clean this up a little bit, okay, is we have f of x plus 4. Oh, let's find the inverse of this. So isn't this just y equals to x squared plus 4? Of course. Now the inverse means switch the x and y's. Okay, so this becomes x equals to y squared plus 4. Now, we've got a problem here. Now let me just pause this for a second. I'm going to clean this up, and I'll be right back. Needed the extra room here. So let's solve this guy here for y. Okay, fine, I can do that. Bring the 4 over, bring the 4 over. Look what we've got. That's that, leaving you x minus 4 equals to y squared. So we have to take the square root, but don't forget one of the wonderful principles that I taught you last year. For those people who've had me before or watched podcasts in the past, you know that this is the Cosmo principle, or what we call the square root principle. Okay, the square root of y squared is just y, but the square root of this ends up being x minus 4 plus or minus. Yes. In other words, we have actually two equations that we have to add in here in order for us to see the result. Okay, so let's go back to our graphing calculator now. First thing that I put in my graphing calculator, of course, is the mirror line, y equals to x. But let's go put the original point down. The original graph way up here was x squared plus 4. Okay, here we go. X squared plus 4. Now, let's see what this looks like. There's the diagonal, there's the original. Now, you know and I know that this point here, which we know is 0, 4, the inverse of that better be 4, 0. So it should be out here. 1, 2, 3, 4 should be here, and the graph should be opening this way. Okay, so there's the inverse. 4, 0. Just flip the coordinates. That's all you have to do. Real easy, right? Okay, so with that in mind, I'm going to just erase this to keep this nice and clean so that you can see it. But I want to put my original point here. There's my inverse point. Now, here we go. Let's start putting things in here. Remember what the two equations are. One's a plus, the square root of x minus 4. One's a minus, the square root of x minus 4. So let's figure it out. Here we go. Back into y equals 2. So one's going to be the plus of the square root of x minus 4, right? And one's going to be the minus of the square root of x minus 4. Plus or minus because of the square root principle. Let's graph and let's see what you get. And sure enough, there you go. Aha! So are we at that point? You bet we're at that point. Look at how this is mirrored to this, right? And this one here, holy smokes. Oh, I can barely even draw this properly. Would have been mirrored all the way down here somewhere. But you can see how this is actually mirrored quite nicely to this point. Wow, is that ever cool? So I think the most important thing to remember is if you ever have to square root, yup. So let's finish this question off by actually writing the proper notation for this. It is an inverse function, so make sure you put it like that. And it is of x equaling to the plus or minus x minus 4. There you go. Square root principle and everything. What a beautiful question.